All right, everybody, it is time for a video about the mean, the median, and the mode. But before we get into the details on what those are, what does the stat cat have to say? So the mean, median, and mode are known as measures of central tendency. And I'll show you what we mean by central tendency with the first example. All right, so let's take this first example. Remember, when we do statistics, we almost always start with the raw data, okay? So let's say the raw data this time are the 4 test grades in statistics class. So say a person has these 4 test grades. Test 1 was a 90, test 2 was an 85, 3 was a 92, and then test 4 was an 83. So as far as these numbers go in this data set, the way that you calculate the mean is you add all the data entries together. So 90 plus 85 plus 92 plus 83. So those were the 4 entries in the data set right there. And then you divide by how many entries there are. Okay, so there were 4 entries in this data set. All right, so it's a pretty simple mathematical formula as far as mathematical formulas go. All right. So when I do that, if I take 90 plus 85 plus 82 plus 83, and then I divide by 4, I get 87.5, and that number is the mean of this data set, okay? Now, the mean is often just called the average in ordinary speak, and maybe like with any class that you have taken, you have heard of your average grade or something like that. Or in sports statistics, like in baseball, you have a batting average and so on. So like you hear the word average thrown around a lot more than mean, but in our class we'll call it the mean because that's normally what statisticians say. Okay, so there's the mean of this data set, or I could say that's the mean grade. Now let's go back to what the stat cat said in the beginning. The mean, median, and mode. Okay, now right now we're talking about the mean though, but they are all measures of central tendency. So what does that mean? I think it's best explained visually. So what I did here is I drew a scale so that we can visualize all the numbers. Okay, so my scale here is, I made it with a ruler, the marks are nice and even, and so on and so forth. So let's visualize it. So I got the 4 test grades up here, right? Test 1, 90, and then 90, 91, 92. That was test 3. And if I count backwards, that's 85, test 2, 84, 83. That was test number 4. So there are the 4 test grades. Where does the mean fit in with respect or relation to the test? It's right here. So let's see, 85, 86, 87. So 87.5 would be right in the middle of 87 and 88. So that's the mean. Now, do you see it? It's right in the middle. Okay. So maybe the test grades are kind of all scattered around, but the mean as a measure of central tendency is trying to tell you where the middle is, or where the numbers are clustered around. Okay, and where's the middle of that? All right, notice the mean is not out in the hundreds. That wouldn't be in the middle, would it? And notice the mean is not in the 70s. That wouldn't be in the middle in it either, right? Okay. So now it's a little more complicated than that, but this example here gives you, I think, pretty good idea of what we mean by central tendency. Okay. Now the mean will not look like this with all data sets, but this is, like I said, gives you a pretty good notion of what we mean by the middle or central tendency for that number. All right, now that's how you calculate the mean. All right, let's talk about the median and the mode. So for those, I'll give a description. I don't really have a mathematical formula to give you. But let's say the median is the middle of the data set when the data are ordered. Okay, so if you order them from least to greatest, you'll find a number in the middle. I'll show you what we mean by that with an example. But all right, that's the median. And the mode is the data entry that is the most common or the most frequent, okay? Some fine print to that. If no data entry is repeated, there is no mode, okay? And if 2 entries are repeated the same amount, then each entry is the mode, okay? All right, so let's do this. Let's say here's my sample data set. And these numbers are just numbers I've put on paper for the sake of example, all right? Now, all right, I've got them in order. 1, 1, 4, 7, 12, 15, 15, 15, and 20. And let's see, how many are there? 1, 2, 3, 4, 5, 6, 7, 8. There are 9 numbers, okay? So when there are an odd number of entries in the data set, there will be a number that's right in the middle. So look, this 12, there's 4 numbers below that, and there's 4 numbers above that. And so 12 is the median. It is the exact middle of the data set. There are 4 entries less than 12, and there are 4 entries more than 12, okay? That's what, in basic terms, the median is. Now, if the data set has an odd number of values, there will always be a number that's right in the middle, okay? Half of them will be below, and half of them will be above. Okay, so 12 will be the median. What do we say about the mode, the data entry that is the most common? Common meaning it's repeated more than the others? Well, so I notice here that 1 is repeated, and it's there twice. But 15 is repeated, but it's there 3 times. So 15 is the most common number in the data set. So 15 is the mode, all right? Okay, so that's what the median and the mode are with a simple example. Now, the median will be the number right in the middle if there are an odd number of data entries. So I need to talk about the case where there's an even number of data entries. So let's look at an example that I got off of my math lab, all right? So how about this? Let's give the raw data as tuition and fees in thousands of dollars for the top 14 universities. Okay, now when I found this question on my math lab, the data were not ordered, but I used StatCrunch to order them. Okay, and then I wrote down that list. So like at the bottom, in at least price of the top 14 universities was $35,000 a year. My goodness. Anyway, then 39 and 41, 41, 42, and so on and so forth, okay? Now, here there are 14 total entries in the data set, all right? Now, remember, I said if there's an odd number of entries, you can pick the one that's right in the middle, meaning with an equal number below it and an equal number above it, okay? If there's an even number, then you'll have to identify the middle 2. So like, in other words, if I can pick the middle 2 such that there's an equal number below the middle 2 and an equal number above the middle 2. So in this case, with 14 numbers in the data set, the middle 2 are 42 and 43, because with regards to that, now you're focusing right here. See those 2 right there? There are 6 below it, and there are 6 above it. So it's like this is the middle, but we need to go a little further than that. Once you identify the 2 numbers that are right smack in the middle, with an equal number below and above, to calculate the median, you find the mean of those 2 numbers in the middle. So what's the mean? What's the mean of 42 and 43? Remember the first example we gave? How do you find the mean of a set of numbers? You add those numbers together and you divide by how many numbers there are. Okay, so I want to find the mean of 42 and 43. So I take 42 plus 43, and that's 2 numbers, so I divide by 2. So that's 42.5. Okay, so the median is the mean of those two numbers that are right in the middle. That's how you do it when there's an even number. All right. Now, it's a quick summary. When there's an odd number of data entries, there will be a number right in the middle with an equal number below it and above it. Okay. All right. If there is an even number of data entries, there will be a pair of numbers or two numbers that are in the middle with an equal number below it and above it. Okay, find the average of those, find the mean of those, and that's the median in that case. All right. So that's a special kind of example that I want to talk about. Let's talk about the weighted mean now. So I guess this one's important for our class. To give you an example of the weighted mean, I got some numbers from our syllabus for how I'm going to calculate the final grade. So in our syllabus, or actually what I call the course information document, but whatever, here's the information. Tests are 75%. I can say they have a weight of 75%. Quizzes have a weight of 15%. And homework has a weight of 10%. So what do the percents mean? And when I say that those are the weights, 75%, 15%, 10%, well, what do you mean by weight? Okay, so let me show you. There's a simple calculation behind this. So let's say that this is how I'm going to calculate your final grade. In addition to that, let's say your mean or average test score is 87. Your mean or average quiz score is 97. And your mean homework score is 95. Then here's how I find the final score. It is the weighted mean of these scores. So, like this. If tests are 75% and your mean test score is 87, I take 0.75 times 87. 0.75 is the decimal equivalent to 75%. And if homework is 10%, if quizzes are 15% and your quiz score, your average mean quiz score is 97, then I take 0.15 times 97. And then for homework is 10%, so the decimal equivalent of that is 0.10 times your mean homework score, which is 95. Okay, and do that in your calculator, you get 89.3, almost an A. You might think, oh, you're going to get an A with a mean quiz score of 97 and a mean homework score of 95. Well, that's where the weights come in. You see, if I say 75% test, your test average has the most influence by far on the grade, way more than quizzes or tests or quizzes or homework at 15 and 10%. So that's why even with these very high mean quiz and homework scores, that test score with the majority weight in the class has the most influence at the grade and keeps you just below an A. All right, so keep that in mind. All right, so that's how you calculate weighted means. The weights will have to be given. Okay. Also, just real quick. So you know how I just casually said 75%, and then when I do the calculation, I use the number 0.75. So if, real quick, 75%, that's what we say, when we talk about things, we say 75%. But we calculate with a different number. Percent means parts out of 100. So the number we use to calculate 75% is 75 over 100. Now, what explains 0.75? Well, whenever you divide a number by 100, you move the decimal place, which, is right here, 75.0. You move the decimal place 2 spots to the left, so you get 0.75, okay? So that's the number I use to calculate. So I say 75%, but I do any calculations with that number using 0.75, all right? Okay, let's look at one last weighted mean example. Well, I guess this is sort of a kind of a combination of just calculating the mean and calculating the weighted mean. So let's say that this is the situation that we encounter. For the month of April, a checking account has a balance of $517 for 25 days out of the month, $23.47 for 3 days out of the month, and $234 for 2 days. What is the account's mean daily balance? So it seems like that's asking for like the mean balance, like $517, $2,347, $234. It's like, what of those balances? It's like it's asking for the mean. But do you think it would be accurate if I took 517 plus 2347 plus 234 and I divided that by 3? Like, that wouldn't be accurate, would it? Why not? Well, because, to just find the mean of these three numbers does not account for the fact that for almost the entire month, the balance was $517. And for only 3 days, was it significantly more than that? Like, 4 times is great. So somehow we need to account for that most of the month the balance was 517, and for very few days was it this bigger number, 2347. Okay, so we'll have to account for the days, not just what the balances were, but how many days the balance was. Now you can think about it like this. Wouldn't it be more accurate like if the data set was the number 517 25 times, and then the number 2347 3 times, and then the number 234 2 times? Wouldn't that be, because that'd be like every day of the month, okay? So that's what we'll do. So it's kind of like a weight in the last example. I have to give the most weight to this number because that was the balance, the most number of days. So this is what we'll do. For 25 days, the balance was $517. 3 days, it was $23.47, and for 2 days, it was $234. Divide by 30 days total. Now, I want to tell you that that is just like the very first example. How do you find the mean of a data set? Add all the data entries together, divide by how many data entries there were. So, like in this data set, it's like there's 517, that's this. There were 3 2347s, that's this, and I'm adding them all together. And then there were 2 234s, that's this. And then how many numbers total would that be? 25, 26, 27, 28, 29, 30. There were 30 numbers total, okay? If you do all that with some rounding to the nearest penny, I'll get $681.13. Okay, so that's kind of like the first example and kind of like the weighted example too, okay? All right, so that's how you do it. I hope, though, that you can come away with this example by seeing that if you just used the balances and you left out the days, if you didn't incorporate that information somehow, then it couldn't be right. All right, you have to take account for the days to get an accurate mean daily balance.